In the early decades of the 20th century, physics underwent a transformation so profound that even its architects expressed unease about what they had discovered. Max Planck, who introduced the quantum of action in 1900, later remarked that he had spent more time trying to integrate his discovery into classical theory than developing it. Einstein, whose work on the photoelectric effect helped establish quantum mechanics, never fully accepted its implications, famously insisting that God does not play dice with the universe. These were not the reactions of cautious conservatives resisting progress. These were the responses of scientists confronting something genuinely new, a mathematical formalism that predicted experimental outcomes with unprecedented accuracy while simultaneously resisting any straightforward physical interpretation. The equations worked. What they described, however, remained unclear. This historical tension points toward a problem that extends beyond quantum mechanics itself. Physics has always proceeded by abstracting away from subjective experience, by translating the rich texture of perception into mathematical relationships between measurable quantities. Newton did not need to account for what it feels like to watch an apple fall. He needed only to describe the mathematical relationship between mass, distance, and acceleration. Maxwell did not need to explain the subjective experience of seeing light. He needed only to unify electricity and magnetism into a coherent field theory. This methodological choice to focus on objective, third-person descriptions rather than first-person experience has been extraordinarily successful. It has given us classical mechanics, electromagnetism, thermodynamics, relativity, quantum field theory, and the Standard Model. It has allowed us to predict, manipulate, and understand physical systems with astonishing precision. Yet there remains one domain where this method encounters resistance. When we turn our attention inward, when we examine not just the behavior of physical systems, but the subjective character of conscious experience itself, the standard tools of physics seem insufficient. It is not that physics cannot describe the brain. Neuroscience has mapped neural correlates of consciousness with increasing detail, identifying specific patterns of activity associated with particular mental states. We know which brain regions activate during visual perception, which networks are involved in attention, which chemical systems modulate mood and arousal. We can predict behavioral responses, measure information processing, and even decode certain aspects of perceptual content from brain activity. What we cannot do, what no current physical theory attempts to do, is explain why any of this feels like something. Why is there a subjective, first-person character to conscious experience? Why does seeing red feel different from hearing a tone? Why does anything feel like anything at all? This question is not new. Philosophers have debated the relationship between mind and matter for centuries. What has changed is the precision with which we can now frame the problem. In 1974, philosopher Thomas Nagel published a paper titled, "What is it like to be a bat?" The question was not rhetorical. Nagel was pointing out a fundamental asymmetry in our knowledge. We can study a bat's echolocation system in exhaustive detail. We can map its neural architecture, measure its acoustic emissions, predict its navigational behavior. We can, in principle, construct a complete physical description of how bat echolocation works as an information processing system. Yet no amount of this third-person objective information seems to bridge the gap to the first-person subjective experience of what it is like to be a bat, to perceive the world through echolocation rather than vision. The physical facts, however complete, leave something out: the qualitative, experiential dimension that philosophers call qualia. This is not a failure of current neuroscience. It is not a problem that will be solved by gathering more data or building more sophisticated models. The difficulty runs deeper. It concerns what kind of explanation is possible in principle when dealing with subjective experience. Physics, by design, eliminates subjective perspective. It seeks laws that are invariant across observers, relationships that hold regardless of who is measuring. This is its great strength. But it also means that physics, as currently structured, cannot accommodate the one thing that makes consciousness philosophically puzzling: the irreducibly subjective character of experience itself. David Chalmers formalised this distinction in the mid-1990s by separating what he called the easy problems of consciousness from the hard problem. The easy problems, which are not easy in any absolute sense, concern functional capacities, discrimination, categorization, integration of information, control of behavior, verbal report. These are problems about what the brain does, and they are amenable to standard scientific explanation. We can, in principle, explain how neural systems perform these functions by identifying the relevant mechanisms, tracing information flow, and demonstrating how specific computations are implemented in biological hardware. Progress on these problems is steady and substantial. The hard problem is categorically different. It asks why any physical system, no matter how functionally sophisticated, should give rise to subjective experience. Why should there be something it is like to undergo information integration? Why should certain patterns of neural activity be accompanied by phenomenal consciousness rather than unfolding in darkness as a purely mechanical process? This is not a question about function or behaviour. It is a question about the existence of an inner, experiential dimension to certain physical processes. And here, physics offers no answer. Not because our theories are incomplete, but because they were never designed to address this kind of question in the first place. Consider what a complete physical theory provides. It gives us a mathematical framework relating measurable quantities. It specifies laws governing how these quantities evolve over time. It allows us to predict experimental outcomes and to calculate the behaviour of systems under specified conditions. Quantum mechanics, for instance, provides extraordinarily accurate predictions about the statistical distributions of measurement results. General relativity describes the geometry of space-time with exquisite precision. These theories succeed because they abstract away from subjective experience, focusing instead on objective, measurable properties and their mathematical relationships. But subjective experience is not, in any obvious sense, a measurable quantity. It has no mass, no charge, no position in space. It is not the kind of thing that appears in the equations of physics. This is not an oversight. It is foundational to the scientific method as it has been practiced since Galileo. The move from subjective perception to objective measurement was what made modern physics possible. Galileo distinguished between primary qualities, properties like mass and motion that could be measured objectively, and secondary qualities like colour and warmth, which he regarded as subjective responses rather than intrinsic properties of matter. This distinction allowed physics to proceed mathematically, to describe the world in terms of quantities that could be related through precise equations. The success of this approach has been overwhelming, but it creates a conceptual puzzle when we try to turn it back on consciousness itself. If physics is defined by its method of abstracting away from subjective experience, then it seems unsuited by its very nature, to explain why subjective experience exists. The tools that allowed physics to succeed in describing the objective world may be the same tools that prevent it from addressing the subjective dimension of reality. Some argue this reveals a limitation of physics. Others argue it reveals a confusion about what explanation requires. Philosophers like Joseph Lavine have pointed to what they call the explanatory gap, the apparent inability of physical descriptions to logically entail facts about conscious experience. Even if we accept that brain states are identical to mental states, there remains something puzzling about this identity. We can understand why water is H2O once we learn enough chemistry. The macroscopic properties of water follow from the microscopic properties of H2O molecules in a way that feels explanatory, but no amount of information about C fibers firing seems to entail, in the same way, that pain feels like this. The connection remains opaque. This opacity has led some philosophers to conclude that consciousness cannot be physical. If no physical facts entail facts about experience, then experience must be something over and above the physical. This would require expanding our ontology, accepting that the world contains not just matter and energy, but also irreducible mental properties. Others resist this conclusion. They argue that the explanatory gap reflects limitations in our concepts rather than a genuine ontological divide. We simply lack the conceptual framework needed to see how physical processes give rise to experience. This does not mean the connection is mysterious. Here it means our current understanding is incomplete. A thought experiment proposed by Frank Jackson in 1982 sharpens this debate. Imagine Mary, a scientist who has spent her entire life in a black and white room. She has access to all physical information about color vision, wavelengths of light, retinal processing, neural pathways, everything physics and neuroscience can tell us about how humans perceive color. Then one day, she leaves the room and sees color for the first time. Does she learn something new? If the answer is yes, if seeing red teaches Mary something that all the physical facts did not, then it seems that physical information alone cannot capture everything there is to know about conscious experience. There is a subjective dimension that eludes physical description. Jackson himself later rejected this conclusion, but the intuition remains powerful. Physical theories describe structure and function. They tell us how systems behave, how they process information, how they respond to inputs. They do not tell us what it is like to be that system, and this seems to be a principled limitation, not a temporary gap in our knowledge. The question, then, is whether this limitation is merely epistemic, a constraint on what we can know, or ontological, a reflection of what actually exists. Does physics fail to explain consciousness because we have not yet found the right theory, or because consciousness is not the sort of thing that physical theories were designed to explain? The answer is not obvious. It depends on what we mean by explanation, what we consider to be fundamental, and what role subjective experience plays in our overall picture of reality. This uncertainty is not a failure of science. It is an indication that we are confronting something genuinely difficult, something that resists assimilation into our existing frameworks. Physics has been successful precisely because it found a way to proceed without addressing these questions directly. But the questions remain, and understanding why they remain may tell us something important about the scope and limits of physical explanation itself. To understand why physics cannot explain subjective experience, we might begin by asking what physics is designed to explain in the first place. This is not a trivial question. Physics emerged from a deliberate choice made by early modern thinkers. Galileo, Descartes, Newton, to focus exclusively on those aspects of nature that could be quantified, measured, and expressed in mathematical laws. This was not an oversight, it was strategy. Before this methodological revolution, natural philosophy included everything: colours, sounds, tastes, purposes, meanings. But these qualities proved impossible to systematise. They varied from observer to observer. They resisted mathematical formulation. So the architects of modern science made a radical decision. They would study only the measurable properties of matter: extension, position, motion, mass. Everything else would be set aside. Not denied, just excluded from the domain of inquiry. This division was explicit in Descartes' work. He distinguished between res extensa, the realm of extended matter governed by mechanical laws, and res cogitans, the realm of thinking substance, where sensations and thoughts occurred. The physical world could be studied through geometry and mechanics. The mental world remained outside that framework. This was not meant as a permanent solution. It was an acknowledgement that the new science had a limited scope. Consciousness, experience, and subjective qualities were not part of the project. For 3 centuries, this arrangement worked brilliantly. Physics developed laws that predicted planetary motion, explained thermodynamics, unified electricity and magnetism, and eventually revealed the structure of atoms and space-time. None of these achievements required any reference to subjective experience. The success of physics came precisely from its willingness to ignore the observer's inner life and focus solely on the external patterns that all observers could agree upon. But something changed in the 20th century. Quantum mechanics introduced measurement into the fundamental equations of physics. Observers became part of the formalism. This did not mean that consciousness was affecting physical outcomes. This is a common misinterpretation. But it did mean that physics could no longer pretend the observer was a mere recording device standing outside the system. Observation was an interaction, a physical process with physical consequences. Yet even here, nothing in the equations addressed what it was like to observe. The formalism treated observation as an abstract operation. The subjective dimension remained invisible. This brings us to the core problem. Suppose you want to explain why a certain pattern of neural activity corresponds to the experience of pain. Physics can tell you how neurons fire, how signals propagate, how neurotransmitters bind to receptors. It can describe the causal structure in exhaustive detail. But nowhere in this description does the experience itself appear. The equations describe dynamics, correlations, information flow. They do not describe what pain feels like. They cannot. The very framework of physics was designed to exclude such descriptions from the start. Thomas Nagel sharpened this issue in his 1974 essay. He pointed out that no amount of information about a bat's echolocation system, frequencies emitted, neural processing, spatial mapping, could convey what it is like to experience the world through echolocation. The physical facts are one thing. The subjective character of experience is another, and the gap between them is not incidental. It is structural. Physical descriptions are objective. They describe systems from the outside, in terms that apply regardless of perspective. Experiential descriptions are subjective. They describe systems from the inside, capturing what it is like to be that system. These are fundamentally different modes of description. This is not a problem unique to neuroscience. It applies to any attempt to explain experience in physical terms. Consider colour. Physics tells us that light at 650 nanometers stimulates certain photoreceptors in the retina, which sends signals to the visual cortex, which processes them in specific ways. All of this can be mapped in detail, but the redness of red, the qualitative character of the experience, does not appear anywhere in this account. We know which wavelengths correspond to which colour experiences, but we do not know why those wavelengths produce those experiences rather than others, or why they produce any experience at all. Some philosophers argue that this gap is merely epistemic. We cannot currently see how physical processes give rise to experience, but this reflects a limitation in our understanding, not a limitation in nature. The analogy here is to historical cases where seemingly mysterious phenomena were eventually explained. Vitalism, the view that living organisms contain a special life force, was abandoned once biochemistry showed how metabolic processes could be explained without invoking non-physical essences. Perhaps consciousness will follow a similar trajectory. Once we understand the brain well enough, the mystery will dissolve. But others argue that consciousness is different. The vitalist made a claim about function, that living organisms do things non-living matter cannot do. Once we explained those functions in physical terms, vitalism had nothing left to explain. Consciousness, however, is not just about function. It is about the presence of experience itself. Even if we explain all the functions associated with consciousness, attention, memory, self-monitoring, we have not explained why those functions are accompanied by experience. Why does information processing in the brain feel like something? Why is there a subjective dimension at all? This is what philosopher Joseph Lavine called the explanatory gap. Even if we accept that brain states are identical to mental states, the connection between them remains opaque. We can understand why water is H2O once we grasp the molecular structure and how it gives rise to macroscopic properties. But no molecular level description of neural activity seems to entail that there is something it is like to undergo that activity. The inference from structure to experience does not feel explanatory in the way that the inference from molecules to liquidity does. David Chalmers formalized this as the distinction between easy problems and the hard problem of consciousness. The easy problems concern explaining cognitive functions, how the brain processes information, integrates sensory input, controls behavior. These are difficult in practice, but they are tractable in principle. We know what kind of explanation would count as a solution. The hard problem concerns explaining why these processes are accompanied by experience. This is not a matter of discovering more facts about the brain. It is a conceptual puzzle. Even with complete knowledge of the brain's physical organization, it seems we could still ask, but why does this system have experiences? One response is to deny the premise. Perhaps the hard problem arises from a confusion about what needs to be explained. Philosophers like Daniel Dennett argue that once we explain all the cognitive functions, discrimination, reporting, attention, there is nothing left to explain. The sense that something is missing reflects an illusion, a cognitive artifact produced by the way we introspect. We think there is a further fact about experience because we are not attending carefully to what our explanations have already achieved. On this view, the hard problem is a philosophical mirage that dissolves under scrutiny, but the intuition persists. When you experience pain, there is something it is like to feel that pain, and that something does not seem reducible to the fact that your nervous system is processing a certain kind of signal. The qualitative character of the experience, the specific way it feels, seems to be an additional fact, not captured by any description of processing or behavior. Explaining why this intuition is so persistent, even among those who study the brain professionally, is itself part of the problem. Another response is to accept the explanatory gap, but deny that it reflects an ontological gap. This is the position of many physicalists who acknowledge that our current concepts do not bridge the divide between physical processes and experience, but who maintain that experience is nonetheless physical. The gap, they argue, is conceptual rather than metaphysical. We lack the framework needed to see how physical organization gives rise to experience. But this does not mean experience is non-physical. It means our conceptual tools are inadequate. Colin McGinn took this further, suggesting that the problem may be unsolvable for creatures like us. Our brains evolved to navigate the physical world, not to understand their own nature. Just as a dog cannot grasp quantum mechanics, we may lack the cognitive architecture needed to see how consciousness arises from matter. The problem is not that consciousness is mysterious in itself, but that it is mysterious to us, given our particular cognitive limitations. This position, called Mysterionism, implies that the hard problem is permanent, not because consciousness transcends physics, but because our minds are not equipped to solve it. There is also the radical option of accepting that experience is not physical. This would require revising our ontology, acknowledging that the world contains irreducibly mental properties alongside physical ones. Some philosophers defend this view, arguing that physics describes only the relational structure of matter, how things interact, but says nothing about the intrinsic nature of matter itself. Perhaps that intrinsic nature is experiential. This is the core of Panpsychism, the view that consciousness is a fundamental feature of reality, present in some form even in basic physical systems. Panpsychism avoids the problem of explaining how experience emerges from non-experiential matter by denying that matter is non-experiential to begin with. But it introduces new puzzles. If electrons have rudimentary forms of experience, how do these combine to form the unified experience of a human mind? This is called the combination problem, and it remains unresolved. Still, for some, Panpsychism offers a more coherent picture than trying to extract experience from purely structural descriptions. What all these positions share is a recognition that the standard tools of physics do not straightforwardly account for subjective experience. Whether this reflects a gap in our knowledge, a limitation in our concepts, or a genuine feature of reality remains uncertain. The fact that such fundamental disagreement persists after decades of careful analysis suggests we are dealing with something genuinely difficult. Not a problem awaiting a clever solution, but a boundary at the edge of our current frameworks. This boundary is not a failure of physics. Physics was never meant to explain everything. It was designed to explain patterns, regularities, structures. It succeeds brilliantly at this. But experience is not a pattern in the same sense. It is the condition under which patterns are perceived. And whether that condition can be captured within the language of physics, or whether it requires a different kind of explanation entirely, is a question that remains open. The question of whether consciousness can ever be explained in physical terms has been debated for centuries, but it acquired a particularly sharp form in the 20th century as physics became increasingly successful at explaining nearly everything else. What emerged was not simply an unsolved problem, but a structural impasse, one that suggests either our current conceptual tools are inadequate, or that the nature of consciousness resists the kind of explanation physics is designed to provide. This essay examines that impasse, not as a mystery awaiting resolution, but as a boundary condition revealing something fundamental about the limits of physical description. The challenge begins with a deceptively simple observation. Physics has no difficulty accounting for the behavior of systems. It can predict how neurons will fire, how information will flow through networks, how patterns of activity correlate with reports of experience. What it cannot do, and has never done, is explain why any of this should feel like something. This is not a gap in data. It is a gap in the kind of explanation physics offers. Consider the distinction drawn by philosopher David Chalmers between what he called the easy problems and the hard problem of consciousness. The easy problems involve explaining cognitive functions, how the brain discriminates stimuli, integrates information, controls behavior. These are tractable because they concern capacity that can be described in functional terms. We can specify inputs, outputs, and transformations. We can build models, test predictions, refine theories. The methods of science apply straightforwardly. The hard problem is different. It asks why any of these processes are accompanied by subjective experience. Why does processing visual information produce the sensation of redness? Why does damage to tissue produce the feeling of pain? A complete functional account can explain what the system does, but it leaves untouched the question of why doing those things feels like anything at all. This is not a matter of insufficient detail. You could, in principle, map every neuron, every synapse, every electrochemical event in a brain undergoing an experience. You could trace the entire causal chain from stimulus to response, and yet nothing in that description would tell you what it is like to have that experience. The qualitative character, the subjective texture, remains outside the scope of the explanation. Some respond by arguing that this is merely a conceptual confusion. They suggest that once we fully understand the functional organization, the hard problem will dissolve. But this response misses the point. The issue is not that we lack information, it is that the kind of information physics provides, structural, relational, quantitative, does not address the intrinsic character of experience. No amount of additional structure bridges that divide. Frank Jackson illustrated this with a thought experiment known as Mary's Room. Mary is a scientist who knows everything there is to know about the physics of colour vision. She has studied wavelengths, retinal cells, neural pathways, but she has lived her entire life in a black and white environment and has never actually seen colour. One day, she steps outside and sees something red for the first time. The question is whether she learns something new. If physicalism is correct, if all facts are physical facts, then Mary already knew everything there was to know. But intuitively, it seems she does learn something. She learns what red looks like. This suggests there are facts about experience that cannot be captured by physical descriptions, no matter how complete those descriptions are. Jackson himself later rejected this conclusion, arguing that the intuition was misleading. But the argument reveals a persistent tension. Even those who defend physicalism acknowledge that bridging the explanatory gap requires more than pointing to correlations. It requires showing how subjective character arises from objective process, and that has proven extraordinarily difficult. Thomas Nagel approached the problem from a different angle in his essay, What Is It Like to Be a Bat? He argued that no amount of third-person information about a bat's echolocation system could convey what it is like to experience the world through echolocation. The subjective point of view is not reducible to any set of facts describable from the outside. This does not mean bats have mysterious non-physical properties. It means that subjective experience has a perspective-dependent structure that resists objective description. Nagel's point was not about bats specifically. It was about the nature of consciousness itself. Any attempt to explain experience in purely physical terms must translate first-person facts into third-person facts. But the translation seems to leave something out, the very thing that makes experience what it is. This leads to what Joseph Lavine called the explanatory gap. Even if we accept that mental states are identical to brain states, there remains a gap in our understanding of why those particular brain states should have those particular experiential properties. We can observe correlations, but correlations are not explanations. They do not reveal why the connection holds or why it could not have been otherwise. Some philosophers argue that this gap is merely epistemic, a limitation in our current concepts, and that future science will close it. Others maintain that the gap is ontological, reflecting a genuine difference between physical and mental properties. The disagreement turns on whether our inability to see how experience arises from matter is a temporary blindness or a permanent feature of the landscape. One response to the explanatory gap is to deny that it needs closing. Eliminativists argue that our everyday concept of experience is flawed and that mature science will simply replace it with a better vocabulary. On this view, there is no hard problem because there are no qualia to explain. What we call subjective experience is a confused folk psychological notion that will be eliminated, much as talk of phlogiston was eliminated by modern chemistry. But this response seems implausible. Whatever we call it, the fact that there is something it is like to see red or feel pain is not a theoretical posit. It is the most immediate datum we have. Eliminating the concept does not eliminate the phenomenon. It only refuses to address it. Another approach is to accept the gap, but reinterpret what it means. Some philosophers suggest that physics describes the extrinsic properties of matter, how things behave, how they relate to one another, but says nothing about their intrinsic nature. Perhaps the intrinsic nature of matter is experiential. This is the core intuition behind Panpsychism, the view that consciousness is not an emergent property of complex systems, but a fundamental feature of reality present in some form at all levels. Panpsychism avoids the problem of explaining how experience emerges from non-experiential matter by denying that matter is non-experiential to begin with. But it introduces its own difficulties. If fundamental particles have rudimentary forms of experience, how do these combine to produce the unified, structured experience of a human mind? This is known as the combination problem, and it has no obvious solution. Simply asserting that small experiences add up to larger ones does not explain the unity and coherence of conscious states. There is also the Mysterian position associated with Colin McGinn, which holds that the hard problem may be unsolvable for beings like us. Our cognitive faculties evolved to solve practical problems in our environment, not to understand the relationship between matter and mind. Just as a mouse cannot grasp quantum mechanics, we may lack the conceptual resources needed to see how consciousness arises from physical processes. The problem is not that consciousness is inherently mysterious, but that it is mysterious relative to our particular cognitive architecture. This view is frustrating because it offers no path forward. If the problem is unsolvable, inquiry becomes pointless, but it may be the most honest assessment. The history of philosophy is filled with problems that resist solution, not because we lack data, but because the frameworks we use to think about them are inadequate, and there is no guarantee that we can develop better frameworks. What all these positions share is a recognition that the standard methods of physics do not straightforwardly account for subjective experience. Whether this reflects a gap in our knowledge, a limitation in our concepts, or a genuine feature of ontology remains uncertain. But the persistence of the debate itself is telling. If the hard problem were merely a confusion or a failure of imagination, it would have dissolved by now. Instead, it has proven remarkably resilient. This resilience suggests we are dealing with something genuinely difficult, not a problem awaiting a clever solution, but a boundary at the edge of our current explanatory frameworks. Physics has succeeded by abstracting away from subjective perspective, by describing the world in objective, quantifiable terms. But consciousness is the one thing that cannot be fully captured in those terms. It is the condition under which any description is made, and that self-referential structure may place it outside the scope of physical explanation. The hard problem is not a failure of physics. Physics was never meant to explain everything. It was designed to explain patterns, regularities, mechanisms, the things that can be observed, measured, and predicted. And it succeeds brilliantly at this. But experience is not a mechanism in the same sense. It is what mechanisms give rise to, or what accompanies them, or what they are instances of, depending on which interpretation you favour. None of these options fit comfortably within the framework of physics as currently understood. This does not mean consciousness is supernatural or that physicalism is false. It means the relationship between physical processes and subjective experience remains deeply puzzling, and it may continue to remain so, not because the answer is hidden, but because the question itself sits at the intersection of two fundamentally different modes of description, one objective, one subjective, and no one has yet found a way to unify them. Whether such a unification is possible, or whether we are asking for something that cannot, in principle, be given, is a question that remains open. The problem may not reside solely in our explanatory frameworks. It may also lie in what those frameworks were built to explain. Physics developed by systematically excluding the subjective. The entire project of mathematical physics, from Galileo through Newton to quantum field theory, was premised on describing nature in terms that did not depend on any observer's particular point of view. Temperature became mean kinetic energy. Colour became wavelength. Sound became pressure waves. Each translation stripped away the qualitative feel and replaced it with quantitative structure. This was not an oversight. It was the method. By removing subjective qualities from the description, physics gained predictive power and universality. The same equations applied whether the observer was human, machine, or hypothetical alien. But in achieving this, physics created a description of the world that was, by design, empty of experience. The map deliberately omitted the territory's most immediate feature, what it feels like to be in it. Now we ask physics to explain what it was constructed to ignore. The situation resembles asking a map of train schedules to tell you what the journey feels like. The map is accurate. It predicts arrivals and departures flawlessly, but it was never meant to capture the sensation of motion, the smell of the station, or the anxiety of missing a connection. Those aspects were excluded from the start because they were irrelevant to the map's purpose. This raises a question about scope. Should we expect physics to explain consciousness, or is consciousness simply outside the domain physics was designed to address? Philosophers of science have long recognized that different explanatory frameworks have limited jurisdictions. Thermodynamics explains heat engines, but not moral decisions. Evolutionary theory explains the diversity of life, but not the curvature of space-time. No one considers these limitations failures. They are acknowledgements that different phenomena require different explanatory structures. But consciousness sits uneasily in this taxonomy. It is not clearly separable from the physical domain. Conscious states correlate tightly with brain states. Damage to specific neural circuits eliminates specific aspects of experience. Anesthetics reliably eliminate consciousness altogether. The physical world and the experiential world are deeply intertwined. Yet despite this interdependence, the explanatory gap persists. One response is to accept the gap as permanent. This is the Mysterian position, most associated with philosopher Colin McGinn, though Thomas Nagel has expressed sympathy for a version of it. Mysterianism holds that the hard problem may be unsolvable, not because consciousness is inherently mysterious, but because we lack the cognitive architecture to solve it. Our brains evolved to navigate a particular environment, to track predators, find food, and cooperate with others. They were not shaped by selection pressures to understand the relationship between neural activity and subjective experience. McGinn draws an analogy to spatial reasoning in animals. A rat can navigate a maze but cannot grasp Euclidean geometry. The rat's spatial cognition is sufficient for its needs, but insufficient for abstract mathematics. Similarly, humans may possess cognitive faculties adequate for building bridges and predicting eclipses, but inadequate for understanding how matter gives rise to mind. The problem is not that consciousness is mysterious in itself. The problem is that it is mysterious relative to us. This view is intellectually humbling, but also frustrating. If the hard problem is cognitively closed to us, then inquiry becomes futile. We are left in the position of the rat staring at a geometric proof, capable of perceiving the symbols, but incapable of grasping their meaning. Mysterianism offers no path forward, only an explanation for why no path exists. Yet the Mysterian argument rests on an assumption that may not hold. It assumes that understanding consciousness requires a specific type of cognitive capacity we happen to lack, but it is not obvious what that capacity would be. We can describe neural processes in extraordinary detail. We can model information integration, attention, memory, and decision-making. We can simulate networks of billions of neurons. What additional cognitive ability would allow us to see why these processes feel like something? The Mysterian might respond that we cannot even imagine what such an ability would look like, which is precisely the point. Just as the rat cannot conceive of what is missing in its understanding of geometry, we cannot conceive of what is missing in our understanding of consciousness, but this response is self-sealing. If we cannot specify what is missing, we also cannot determine whether anything is actually missing. The argument becomes immune to counterexamples. A different approach questions whether the hard problem is a problem at all. Some philosophers argue that it arises from confused concepts or mistaken assumptions. Once we clarify our thinking, the puzzle dissolves. This is the deflationary strategy pursued by thinkers like Daniel Dennett and various proponents of illusionism. Dennett argues that consciousness is not what it seems. We believe we have rich, vivid, continuous streams of experience, but this belief is itself part of the system's self-model. In reality, there is no Cartesian theatre where experiences are presented to a central observer. There is only a distributed process of information handling, which generates a simplified narrative for behavioural purposes. What we call qualia, the redness of red, the painfulness of pain, are not intrinsic properties of experience. They are judgments the system makes about its own states. On this view, the hard problem evaporates. There is no mystery about why brain processes feel like something, because they do not feel like anything in the sense the hard problem assumes. The apparent gap between physical description and subjective experience is a confusion. We have mistaken a useful fiction, the story the brain tells itself, for a deep ontological feature. This position is bold, but it struggles with phenomenology. When you stub your toe, it does not feel like a judgment about a neural state. It feels like pain. The qualitative character of the experience seems undeniable. Dennett's response is that this sense of undeniability is itself part of the illusion. The brain is designed to present its states as immediate and self-evident. But design does not imply truth. Evolution crafted a system that operates on the assumption of robust experience, even if that assumption is false. The deflationary strategy forces a choice. Either we accept that our most direct and certain knowledge, the fact that we experience anything at all, is an illusion, or we admit that something about experience resists physical explanation. Both options are uncomfortable. The first denies what seems most obvious. The second suggests a permanent explanatory gap. Meanwhile, another class of approaches attempts to bridge the gap, not by denying experience, but by expanding what counts as physical. These are the panpsychist and Russellian monist strategies. They argue that standard physicalism is incomplete. Physics tells us what matter does, how it moves, interacts, and evolves, but it does not tell us what matter is. The equations describe behaviour, not intrinsic nature. Bertrand Russell and Arthur Eddington proposed in the early 20th century that physics only captures the extrinsic, relational properties of matter. Mass, charge, and spin describe how particles respond to forces and interact with one another. But these properties do not specify what a particle is in itself, independent of its relations. Russell suggested that the intrinsic nature of matter might be experiential, not conscious in the human sense, but possessing some minimal form of subjectivity. This is panpsychism, the view that consciousness is not a late arrival in a purely physical universe, but a fundamental feature present at all levels. Electrons do not think or feel pain, but they may possess some primitive form of proto-experience. Complex consciousness, like ours, emerges when these micro-experiences combine in the right way. Panpsychism avoids the combination problem faced by emergentist theories. If experience is already present at the fundamental level, we do not need to explain how it arises from non-experiential matter. We only need to explain how simple experiences combine into complex ones. But this replacement problem is not obviously easier. How do a trillion micro-experiences in neurons combine into a single unified conscious state? Why do they not remain separate? Panpsychists offer various answers: integrated information structures, special binding mechanisms, or forms of mental composition analogous to physical composition. None of these proposals has achieved consensus. The combination problem remains as difficult as the original emergence problem, possibly more so. Yet panpsychism has gained traction in recent years, not because it solves the hard problem, but because it repositions it. Instead of asking how consciousness emerges from matter, we ask how simple forms of consciousness combine into complex ones. This may or may not be progress, but it shifts the explanatory burden in a way some find more tractable. What unites all these responses, Mysterionism, Deflationism, Panpsychism, is that none appeals to new physics. They do not propose undiscovered forces or particles. They operate within the framework of known physical law, reinterpreting what that law means or what it leaves out. This is telling. The hard problem is not a gap in physical theory that future experiments might fill. It is a conceptual puzzle about the relationship between two fundamentally different kinds of description. Physics describes the world in third-person terms. It specifies what happens, where, and when, using concepts accessible to any observer. Experience is inherently first-person. It is what it is like for a particular subject. These two perspectives seem incommensurable. Bridging them may require not just more data, but a new framework that accommodates both. Whether such a framework is possible remains uncertain. Some believe we need a revolution in thought comparable to relativity or quantum mechanics. Others think the problem is intractable. Still others argue it is a pseudo-problem born of conceptual confusion. What is clear is that physics, as currently practiced, does not resolve it. The tools that allowed us to predict planetary motion and explain atomic structure do not extend straightforwardly to explaining why anything is experienced at all. This is not a failure of physics, it is a recognition of its boundaries, and yet, even recognizing these boundaries, some physicists cannot help but wonder whether the problem might yield to a different kind of physical theory altogether. Not Mysterionism, not deflation, not Panpsychism, but a physics that includes consciousness as a fundamental ingredient from the start. This is where the conversation becomes most speculative and most contentious. The idea is not new. In the early decades of quantum mechanics, several physicists proposed that consciousness might play an active role in the collapse of the wave function. Observers were not just recording outcomes, they were, in some sense, participating in the creation of definite reality from quantum indeterminacy. This was the von Neumann-Wigner interpretation, named after mathematician John von Neumann and physicist Eugen Wigner. Von Neumann's work suggested that the chain of physical causation could not by itself terminate the quantum superposition. Something outside the physical system, consciousness, had to perform that final act of collapse. Wigner took this seriously. He argued that consciousness was the only known entity capable of breaking the infinite regress of measurement. If every measuring device is itself a physical system obeying quantum rules, then it too should exist in superposition until observed by something else. The chain extends indefinitely unless it terminates in something non-physical. Consciousness, being subjective and irreducible, seem to fit that role. This interpretation was never widely adopted. Most physicists found it too vague, too dependent on undefined terms like consciousness and observation. What counts as an observer? Does a cat suffice? A bacterium? A photodiode? Wigner's answer was that only a conscious being could collapse the wave function, but this raised more questions than it answered. If consciousness is necessary, how did the universe evolve before conscious observers existed? Wigner suggested that consciousness might be more widespread than we think, perhaps even fundamental, but this moved dangerously close to panpsychism, which most physicists rejected. Moreover, subsequent developments in quantum theory made the von Neumann-Wigner interpretation seem unnecessary. Decoherence theory, developed in the 1970s and 1980s, showed that quantum systems interacting with their environment lose their coherence rapidly, behaving classically without requiring a conscious observer. The wave function does not collapse in a literal sense. It becomes entangled with the environment in such a way that different branches of the superposition cease to interfere. This explains why macroscopic objects appear definite without invoking consciousness. Decoherence dissolved much of the motivation for consciousness-based interpretations. If the environment alone suffices to explain classical behaviour, consciousness is explanatorily redundant, yet the interpretive question remains. Decoherence does not solve the measurement problem, it only shifts it. We still must decide whether the wave function represents reality or merely our knowledge, and whether the branches are real or just mathematical artifacts. These are interpretive choices, not empirical facts, and consciousness could still enter at that level, not as a physical cause but as a metaphysical necessity. Some contemporary physicists, notably Roger Penrose and Stuart Hameroff, have proposed that consciousness might emerge from quantum processes within neurons. Their orchestrated objective reduction theory suggests that microtubules, protein structures inside cells, support quantum coherence long enough for quantum effects to influence neural computation. Penrose argues that consciousness requires non-computable processes, which he believes arise from quantum gravity effects at the microtubule scale. When the quantum state reaches a certain threshold, objective reduction occurs, producing a moment of conscious experience. This is not the von Neumann-Wigner interpretation. Penrose does not claim consciousness causes wave function collapse. Instead, he proposes that collapse and consciousness are two aspects of the same process. Objective reduction happens in physical systems according to quantum gravity principles, and when it occurs in appropriately organized biological structures, it is accompanied by subjective experience. The theory remains highly controversial. Most neuroscientists and physicists argue that the brain is too warm and noisy to sustain quantum coherence for any significant duration. Decoherence times at biological temperatures are measured in femtoseconds, far too short for quantum states to influence neural activity. Hameroff counters that microtubules might possess special properties that protect quantum coherence, but experimental evidence for this is weak. Several studies have looked for quantum effects in microtubules and found none. Even if such effects existed, it is unclear how they would translate into the specific features of consciousness: qualia, intentionality, the unity of experience. Penrose's appeal to Gödel's incompleteness theorems to argue for non-computability is also disputed. Most logicians and computer scientists do not accept that human thought is non-computable in the relevant sense. The incompleteness theorems show that no formal system can prove all truths about arithmetic, but this does not imply that human mathematicians transcend formal systems. We might simply be using different formal systems at different times or operating heuristically without access to all truths. The leap from Gödel to quantum gravity to consciousness involves several speculative steps, each of which requires independent justification. What is instructive about Or, regardless of its validity, is the kind of move it represents. It attempts to ground consciousness in physics by proposing a specific mechanism, quantum processes in microtubules, and linking that mechanism to a physical theory, quantum gravity. This makes it testable, at least in principle. If future experiments demonstrate quantum coherence in microtubules under physiological conditions, and if that coherence correlates with conscious states, Or gains empirical support. If experiments consistently show rapid decoherence and no correlation, the theory fails. This is how science proceeds. Speculative ideas are formulated, predictions are derived, experiments are conducted. Most speculative ideas fail. That is not a flaw, it is the process. The hard problem, however, resists this approach because it is not clear what would count as a successful explanation, even if we discovered a perfect correlation between quantum events in microtubules and conscious states. We would still face the question, Why does this physical process feel like something? Why is there subjective experience associated with it? This is the core of the explanatory gap. Correlation is not explanation. Knowing that certain neural states accompany certain experiences does not tell us why those states are experienced, rather than merely processed. Penrose and Hameroff can point to quantum events, but they cannot explain why those events have an inside, a first-person character that other physical events lack. Some philosophers argue that this is because we are asking the wrong kind of question. Explaining why something feels a certain way may be categorically different from explaining how it works. Physics explains mechanisms. It tells us what happens, when, and under what conditions. But the request to explain why anything feels like anything may be a request for a different kind of answer, one that physics, by its nature, cannot provide. Consider an analogy from mathematics. We can prove that certain mathematical structures exist and describe their properties exhaustively, but if someone asks, why does this structure exist rather than not exist? Mathematics has no answer. Existence in mathematics is not explained. It is posited. Similarly, perhaps subjectivity is not something that can be derived from objective facts. It might be a primitive feature of reality, irreducible to anything else. If that is true, then physics will never explain subjective experience in the way it explains other phenomena. Not because physics is incomplete, but because explanation has limits. Some facts may simply be brute facts, features of reality that cannot be reduced to anything more fundamental. This possibility is uncomfortable for physicists. The entire project of physics is to find deeper explanations, to reduce complex phenomena to simpler laws. The idea that some aspects of reality are irreducibly primitive seems like giving up. Yet history offers precedents. The existence of space and time, the values of fundamental constants, the laws of quantum mechanics themselves, all of these are, in current physics, unexplained. We can describe them, measure them, use them to predict other phenomena, but we do not know why they have the form they do. They are boundary conditions for explanation, not things that are themselves explained. Consciousness might occupy a similar status. We can study its neural correlates, its functional properties, its evolutionary origins. But the fact that it exists at all, that there is something it is like to be a conscious organism, may be a boundary condition, a starting point for inquiry, not a conclusion to be derived. If this is correct, then the hard problem is not a problem awaiting a solution. It is a recognition of a conceptual limit. Physics describes the world from the outside in objective terms. Consciousness is the inside, the subjective. Bridging the two may require not just more data, but a reconceptualization so fundamental that we cannot yet imagine what it would look like. Some believe that reconceptualization will come. They point to past scientific revolutions, the shift from Newtonian mechanics to relativity, from classical to quantum physics, as evidence that our concepts can change radically while still advancing understanding. Perhaps a future physics will incorporate subjectivity in a natural way, making the hard problem dissolve. Others are skeptical. They argue that the subjective-objective distinction is not a matter of incomplete theory, but of irreducible categories. No amount of objective description, however complete, will ever capture what it is like to see red. This is where the debate stands. Physicists, philosophers, and neuroscientists continue to propose theories, conduct experiments, and refine concepts. Progress is made in understanding the neural correlates of consciousness, the functional properties of awareness. the evolutionary advantages of subjective experience. But the hard problem, the question of why anything is experienced at all, remains as hard as ever. It is not a question physics can avoid. Consciousness is the most immediate datum we possess. Every observation, every measurement, every scientific inference passes through it. To say that physics cannot explain it is to acknowledge a gap in the most successful intellectual project in human history. That gap may eventually close, or it may be permanent, a reminder that the map is not the territory, and that some territories lie beyond the reach of any map we can draw. Yet the difficulty of bridging this explanatory divide does not mean the effort is misguided. Understanding the relationship between physical processes and subjective experience remains one of the deepest challenges facing science. The tools we have, functional imaging, computational modelling, neural recording, continue to improve. They reveal increasingly detailed maps of how the brain processes information, how neural circuits generate behaviour, how consciousness correlates with specific patterns of activity. These are not trivial achievements. They represent real progress in understanding the mind as a biological system. But progress in mapping correlations does not automatically yield progress in explaining why those correlations exist. Knowing that neural activity in the visual cortex corresponds to the experience of seeing red does not tell us why that activity is accompanied by experience at all. The correlation is robust, repeatable, and scientifically valuable. The explanation remains absent. This has led some researchers to propose that the answer lies not in more detailed neuroscience, but in a shift of framework. Perhaps consciousness is not something that emerges from complex computation, but something that is already present, in rudimentary form, in simpler systems. This is the core claim of Panpsychism, the idea that experience is a fundamental feature of reality, not unique to brains, but distributed throughout nature. Panpsychism has ancient roots, but its modern formulations are motivated by contemporary physics. The argument proceeds from a simple observation. Physics describes matter in terms of its extrinsic properties, how it behaves, how it interacts, what it does. Mass tells us how matter responds to force. Charge tells us how it interacts with electromagnetic fields. Spin describes its intrinsic angular momentum. But what is matter in itself, independent of its effects? Physics is silent on this question. Bertrand Russell and Arthur Eddington, writing in the early 20th century, suggested that the intrinsic nature of matter, the stuff that underlies its measurable properties, might be something experiential. Not consciousness in the human sense, but something proto-experiential, a primitive form of subjectivity that, when organised in the right way, gives rise to the rich inner lives we associate with brains. This proposal is not scientifically testable in the usual sense. There is no experiment that could detect primitive experience in an electron, but it offers a conceptual advantage. It avoids the problem of explaining how experience arises from wholly non-experiential matter. If experience is already present in some minimal form at the fundamental level, then the hard problem is reframed. The challenge becomes not explaining the origin of experience, but explaining how simple experiences combine to form complex ones. Yet this move introduces new difficulties. How do individual micro-experiences combine into a unified conscious field? Why does a brain produce a single, integrated experience rather than a swarm of disconnected micro-experiences? These are known as the combination problem and the boundary problem, and they are as difficult as the original hard problem they were meant to solve. Moreover, Panpsychism requires accepting that experience is ubiquitous, that even systems we do not normally consider conscious, rocks, atoms, thermostats, possess some form of subjectivity. This claim strikes many as extravagant, an ontological burden that outweighs any explanatory benefit. If we cannot test it, cannot falsify it, and cannot derive clear predictions from it, then what role does it play in science? These objections are serious, and they highlight a recurring tension in the study of consciousness. Every proposed solution seems to generate new problems of equal or greater difficulty. Physicalism faces the hard problem. Dualism faces the interaction problem. Panpsychism faces the combination problem. Each framework offers certain conceptual advantages while incurring specific costs. None has achieved consensus. This state of affairs suggests that the problem may not be with any particular theory, but with the conceptual tools we're using. Thomas Nagel has argued that understanding consciousness may require a conceptual revolution so fundamental that we cannot yet imagine what it would look like. We might be in the position of pre-Newtonian thinkers trying to understand gravity without the concept of force, or pre-quantum physicists trying to understand atomic structure without the concept of wave-particle duality. The right concepts may simply be unavailable to us at this stage. If this is correct, then the hard problem is not a sign that consciousness lies outside the scope of science. It is a sign that science has not yet developed the conceptual framework necessary to address it. This is a more optimistic view than Mysterionism, which holds that the problem is unsolvable in principle. But it is also a more patient view. It acknowledges that some problems take centuries to solve, not because the answers are hidden, but because the questions themselves need to be reformulated. Consider the history of life. For much of human history, the origin of living organisms was regarded as fundamentally mysterious. How could non-living matter give rise to living beings? The question seemed intractable. Then Darwin provided a framework, natural selection, that showed how complexity could arise from simpler processes over time. The mystery did not vanish overnight. Many aspects of biology remained unexplained, but the conceptual breakthrough made progress possible. The question became answerable in principle, even if the details took decades to work out. Could something similar happen with consciousness? Could a future scientific framework make the hard problem dissolve? Not by answering it directly, but by showing that the question was improperly posed. This is a real possibility, but it is also possible that consciousness occupies a unique position, that the subjective character of experience is not the sort of thing that admits of explanation in the way other phenomena do. Physics explains the world by describing objective structures and laws. It tells us how things behave, how they interact, how they change over time. But subjective experience is not a behavior. It is not an interaction. It is not a change in state. It is the fact that there is something it is like to be a particular system at a particular time. That fact does not fit neatly into the categories physics uses. This does not mean physics is wrong or incomplete in the usual sense. Physics is extraordinarily successful at predicting and explaining the behavior of physical systems. But it may be that the success of physics is domain-specific, that its methods apply to certain kinds of questions and not others. If consciousness is fundamentally first-person and physics is fundamentally third-person, then no amount of third-person description will fully capture the first-person character of experience. This is not mysticism. It is a recognition of methodological limits. Science is not a single, monolithic enterprise. Different branches of science use different methods, ask different questions, and accept different standards of explanation. Chemistry does not explain everything biology explains, even though biological systems are made of chemicals. Economics does not explain everything psychology explains, even though economic behavior is rooted in psychological decisions. Each level of description has its own autonomy, its own explanatory principles. Consciousness may represent a similar boundary. We can study its neural correlates, its functional properties, its evolutionary history. But the fact that it exists at all, that there is experience rather than no experience, may be a brute fact, something that cannot be derived from more fundamental principles because it is itself fundamental. If this is true, then the hard problem is not a failure of physics. It is a recognition that explanation has limits, that some aspects of reality are primitive, not reducible to anything else. This is not a comfortable conclusion. It goes against the grain of scientific optimism, the belief that every question has an answer waiting to be discovered. But it may be the most honest conclusion available. The debate over consciousness is far from settled. New theories continue to emerge, new experiments continue to refine our understanding of the brain. New philosophical arguments continue to challenge existing frameworks. But the central question remains: why is there subjective experience at all? And the answer for now is that we do not know. This uncertainty is not a reason for despair. It is a reminder that science is an ongoing process, not a finished product. The fact that we can even ask this question, that we can recognize the limits of our current understanding, is itself a form of progress. We know more about what we do not know than we did a century ago. That knowledge, incomplete as it is, shapes the questions we ask next. Physics has given us an extraordinary picture of the universe, its origin, its structure, its fundamental laws, but that picture remains incomplete. The gap between objective description and subjective experience is real, and it is not clear whether that gap can ever be fully closed. Perhaps it cannot. Perhaps the best we can do is acknowledge it, study it from multiple angles, and accept that some mysteries run deeper than our methods can reach. The question of whether physics can explain subjective experience has generated hundreds of papers, dozens of theories, and no consensus. This is not unusual in philosophy, where debates can persist for centuries. What is unusual is that this particular debate involves empirical science, neuroscience, cognitive science, physics itself, yet remains as philosophically contested as questions about free will or the nature of truth. Part of the difficulty lies in what we mean by explanation. In physics, explanation typically means showing how a phenomenon follows from more fundamental laws. We explain planetary motion by deriving it from Newton's laws. We explain atomic spectra by deriving them from quantum mechanics. The derived phenomenon is shown to be a necessary consequence of the underlying principles. If subjective experience could be explained in this sense, we would show how the qualitative character of consciousness follows necessarily from physical laws. But no such derivation exists, and it is not clear what one would look like. This absence might reflect a temporary gap in our knowledge. Perhaps future neuroscience will reveal principles of neural organization that make the connection between brain states and experiential states transparent. Perhaps a deeper understanding of information integration or quantum processes, or something not yet imagined, will close the explanatory gap. This is the optimistic view, and it cannot be ruled out. Science has surprised us before, but it is also possible that the gap reflects something more fundamental, not a missing piece of knowledge, but a mismatch between the kind of explanation physics provides and the kind of understanding subjective experience requires. Physics describes the world in quantitative, relational terms. It tells us how systems behave, how they change, how they interact. Subjective experience, however, is qualitative and intrinsic. It is not defined by behaviour or interaction, but by what it is like from the inside. This difference might be bridgeable. It might be that future concepts will show us how to move from objective description to subjective character. But it might also be that the difference is irreducible, that no third-person account can fully capture first-person reality. If that is the case, then the hard problem is not a puzzle awaiting solution, but a recognition of explanatory limits. What remains clear is that consciousness is not going away. It is the most immediate fact we know. Every scientific observation, every theoretical inference, every experimental result is accessed through conscious experience. To dismiss it as an illusion is to undermine the very foundation of empirical knowledge. Yet to insist that it must be explainable in physical terms is to assume that physics has no boundaries, that its methods apply universally to all phenomena. Perhaps the most intellectually honest position is uncertainty. We do not know whether consciousness can be explained in physical terms. We do not know whether the hard problem will dissolve with better science or persist as a permanent feature of inquiry. We do not know whether our concepts are inadequate or whether the phenomenon itself resists the kind of explanation we seek. This uncertainty is uncomfortable. It leaves us without closure, without a clear path forward, but it is also accurate. The study of consciousness is still in its early stages. Neuroscience has made remarkable progress in mapping the brain, but mapping is not explaining. Philosophy has clarified the conceptual issues, but clarification is not resolution. Physics has provided the most successful framework for understanding the natural world, but that framework was designed to exclude the subjective. Where we go from here depends on what we are willing to accept. If we insist that science must eventually explain everything, then the hard problem becomes a challenge to be overcome. If we accept that some phenomena may lie outside the scope of scientific explanation, then the hard problem becomes a boundary marker, indicating where physics ends and something else begins. Neither position can be proven. Both are defensible. What cannot be maintained is the pretense that the problem is trivial, or that it has already been solved, or that asking the question is somehow confused. The hard problem is real. The explanatory gap is real. The tension between objective description and subjective experience is real. Whether it can be resolved and how remains one of the deepest open questions in both science and philosophy. For now, we continue to study the brain, refine our theories, and test our assumptions. We map neural correlates, build computational models, and explore the boundaries of what can be known. But in doing so, we must acknowledge what we are not doing. We are not explaining why any of this feels like something. We are not bridging the gap between physical process and subjective experience. We are describing, correlating, predicting. These are valuable achievements, but they are not the same as understanding why consciousness exists at all. The question remains open. The methods of physics have not reached it. Perhaps they will. Perhaps they cannot. For now, the honest answer is that we do not know, and recognizing the limits of our knowledge is not failure. It is the beginning of wisdom.